Okay, now I'm going to share the window. Okay, we're going to look into various things in Chapter 1. One of them is we're going to talk about your cell phone, and we're going to look at what cell phone is made up of, what compounds are used in cell phone. And we're going to know that cell phone is made out of certain compounds, and those compounds have elements, atoms of certain elements. They give certain properties, desirable properties to the cell phone. We're going to classify elements in the periodic table using cell phone as an example. So we're going to look at physical, chemical properties, atomic properties, atomic structure, and various materials used in construction industry and in building materials. You guys are familiar with your cell phone. Everybody is holding it all the time. I can see my kids are always with the cell phone, looking at something. What is cell phone is what items the cell phone is made from. Cell phone has screen, electronics, casing, and the battery. So there are 4 major components in the cell phone. We're going to look in detail and find out what cell phone, what material particular component is made up of. For example, touch screen is made from glass, silica, that's it, silica, SiO2, and it's treated with sodium to make it crack resistance. Silica is made from silicon, are found in electronic component of the cell phone, silicon, made from sand. Silicon is elemental silicon. It's a fundamental component of power processor chips. We're going to also look at building material such as glass made from heating sand. How many of you know sand is made from glass, heating it at very high temperature and melting it to a thick liquid and producing various glass materials, windows, bottles, etc. Now there's going to be environmental implications coming from the fabrication process of these items, cell phones, glass, silicon chips, and everything. So you go and later watch the video on how does cell phone works. If you watch the video, you get an idea the properties of how certain material control the properties of electronic devices. What is a desirable attribute of your cell phone? Like crack resistance, screen, waterproofness, and lightweight, and the long lasting battery. So we would like to see improvement in these properties in the future, the longer lasting batteries. And we should be able to use the cell phone in a pool also, like sitting in the pool, you can go underwater and take pictures and stuff like that. What is a lifespan of a cell phone? What do you think it is? How long you used your phone last time? Can you answer the question?
8 years.
8 years? You're pretty good. Most people change phones every 3 years. I use about 5 to 8 years. I change it with my cell phone plan, lease them and pay over the period of time. Now, cell phone has a touch screen. Touch screen are made out of materials with specific chemical and physical and chemical properties. What is physical property that desirable on a touch screen? Crack resistance is one of the physical property. Touch screen make a contact with your finger, then pass an electrical current through the touch screen to your computer, and you can do various manipulations using your finger to go to programs, sending emails and things like that. Have you noticed that touchscreen doesn't work with everything? I was trying to use my touchscreen with a pen, regular pen or pencil. It didn't work. But my touchscreen my phone is a Galaxy 10. It has a stylus. That particular stylus pen has a tip made out of some material which show the same responses as the touch screen touched by your finger. So there you can test different objects, different things, whether it make a response on your touch screen. Now, since we talk about materials that made out of materials that make up the cell phone, we're going to look at material classification little more in detail. As we said before in the introduction, matter is around us, everything around us we can touch and feel. Definition of matter is something that occupies space and mass. Now, I talked in the introduction, there are two ways to look at matter. One is the macroscopic view, as in this atmosphere. You can look at the atmosphere, air, and see the atmosphere. That's a gaseous state. The water molecules are in the atmosphere, in the gas phase. And the chunk of ice in the ocean, that is solid state. In the particulate view or atomic view shows the water molecules are close to each other. And in the liquid water phase, which is the sea or the oceans or the reverse. Water molecules are in close contact, but they can roll over. They can change the shape and move around. So did you see that matter could be seen in macroscopic and atomic view, as in we also call particulate view? Most important thing for chemistry, environmental chemistry, is seeing things in particulate view or atomic view. Matter is divided into states or phase. Phase is another name for state of matter. Phase of matter is same as state of matter. There are 4 basic states of matter: liquid, gases, solids, and plasma. Plasma is not normally found on Earth. It's found in hot stars. They are at a very high temperature. Their atomic structure is broken down. We don't find many things as plasma on Earth. So based on phase, matter is basically 3 things: gas, liquid, or solid. On the macroscopic scale, there are certain properties that are characteristic to solid, liquid, and gases. The solid has definite shape. Solid doesn't take up the shape of the container. Also, solid has definite volume. So read the table here. Liquid has take up the shape of the container. Completely fill the container, no. That's gas only fills up. There are certain properties we ask you to identify different states of matter. We're going to understand difference between physical, chemical properties and physical change and chemical change. Physical properties of matter are their boiling point, at which temperature they boil, or melting point, color, odor, solubility, whether it's dissolved in water like sodium chloride, and the states of matter, whether it's a liquid or gas or solid. During measurement of physical properties, the matter is not changed. For example, if you observe water freezing, the water molecules doesn't change, only they become closer to each other, become solid. Physical changes involve preservation of substances, while physical state of matter is changed. Physical change is mainly like boiling, melting, solubility, and whether it's a liquid or gas. It involves physical changes. Chemical property, on the other hand, determines how a substance can change to another substance. The flammability of a material, for example, natural gas, which is methane, burns in air and produce carbon dioxide and water. So I have listed different chemical properties of substances. Toxicity, how toxic. Toxicity is a chemical reaction that affects the living things or human beings. Acidity is also sourness in the, it is a chemical property. Reactivity, like oxidation, combustion, or radioactivity, are associated with substance being changed to another. Chemical change always involves change in the substance of matter. Another new substance is created. You can watch the physical video on physical and chemical change. To answer a few questions, what is the simulation of atoms and molecules in different states? In the video below. Now you are going to answer following questions about solids, liquids, and gases, and also going to provide a support for each of your answers. What phase has definite volume? Solid have definite volume, and liquid also has definite volume. Examples of solid are copper and mercury. Mercury is a liquid. What phase has a definite shape? We talk about it, solid. Any solid has a definite shape. What phase take up the space of the shape of the container, Liquid take up the shape of the glass which it held. What phase completely fill the container? Gases like helium fills up a balloon or container and take up the shape. Are you guys all right? You're hanging in there?
Yes, sir.
Yeah.
Okay, good. I like your daughter, Caitlin. I have a granddaughter like that.
Well, that's me, and that's my mom in the back.
Good. She's so pretty.
Thank you.
So we have brown kids. Brownie. Okay. The matter could be classified as liquid, solid, gases based on the physical state. And matter also could be classified based on composition, what is made up of. Basically, matter based on composition are two main things. One is the pure substances. One thing about pure substances are they have definite physical properties, chemical as well, physical and chemical properties. Water has a boiling point, melting point, right? And the mixtures are made up of pure substances, one or more different types of pure substances. Therefore, their physical properties are not fixed. It depends on the components. A mixture is a mixture of pure substances, either different element with another element, or element with a water, another compound, or mixture of two different compounds like water and sodium chloride. So we talked about this. Pure substances could be elements or compounds. Elements by composition, if you look at the composition of elements, they have only one type of atom. For example, silicon, copper, oxygen. If anything is made up of molecules containing only one type of atom, it's called element. Compounds, on the other hand, contain two or more different types of atoms. For example, water or silicon dioxide. Silicon oxide is found in quartz or sand. Mixtures could be either heterogeneous, composition is different in different part of the sample. If you take a piece of gravel, one part of the gravel has different things on than the other part. Gravel is a mixture of many minerals. It's heterogeneous. Homogeneous is when everything is uniformly distributed throughout, such as solution, sodium chloride solution in water, or metallic solids when two metals are mixed up and heated up, and when they become a liquid, they are homogeneous solution. Then when you freeze them, it becomes a solid where composition is same throughout. So watch the video on classification of matter by composition and physical state. You're going to understand more. We're going to answer a few questions now. Carbon dioxide is a compound. Why is that? What is the definition of a compound? You guys thinking?
It contains two or more types of atoms.
Yes, carbon is one kind and the oxygen is oxide. Two or more kinds of atoms in a molecule is a compound. It's a one unit, all right? So, some ionic compounds, molecular compounds, ionic compounds have ions like sodium chloride. Sodium ions have chloride ions. Nickel is an element because it's a pure metal consisting nickel atoms. Cocaine is a compound. Do you know what cocaine is? I'm just asking.
Yes, sir.
It's a carbon, hydrogen, nitrogen, oxygen compound. It's a molecule that affect your nervous system, and it's a drug. So painkiller. It's a molecule, it's a compound made out of carbon, hydrogen, and oxygen, more than one type of atom. Water is a compound. Why is water a compound? Water is a common name for H2O. It's made up of hydrogen and oxygen. Fluorine is a gas. Gases that contain only fluorine atoms. Table salt is a compound because it makes out. Table salt is named for sodium chloride. Common name is called table salt. Soap is a mixture. Soap has many things in it. Fatty acid salts, oil, various other film material, and it's a complex mixture. Seawater is a mixture also. It contains water, sodium chloride, magnesium chloride, various other soluble salts are there. Seawater is tasting salty because of mainly this water, is sodium chloride. Now, you don't have to watch the video. Let's answer the question. categorize the following using the schemes that we learn. Your cell phone is what kind of a category of matter it will belong to. It's made out of 4 components that are also complex mixtures. So definitely your cell phone is a complex mixture of various things, material. Aluminum foil is made out, aluminum is made out of aluminum. So therefore atomic, one type of atom is an element. It could be also called a solid. Cell phone is also solid. Red wine is a mixture of homogeneous mixture. Red wine has water, sugar, alcohol, some sugar, alcohol, and coloring material that gives a red color. Chlorine gas is an element. It's a gaseous state. Stainless steel is mainly iron and carbon. Stainless is and other metal atoms. Stainless steel is an alloy. The alloy is something that keep the metallic properties even if you add different compounds into it. There are different types of alloys like brass, copper and zinc, mixture of in the brass. Table salt is a compound, is an ionic compound, is made out of sodium and chloride ion. Sugar is a, what do you think about sugar? What do you think about sugar? Sugar is a what? Mixture? Sugar is a compound made out of carbon, hydrogen, oxygen. Sugar is sucrose. There's a formula for that. It's a molecular compound. It's a compound. Now that we have gone over classification of matter based on composition, and we found out that there are elements, compounds, and mixtures. The fundamental building block of matter is an element with certain properties and certain fixed characteristics. An element is the one that the basic building block of the matter is. We classify these elements, building blocks of matter, in a table called periodic table. How many of you have seen periodic table before? You walk into
I have.
Okay. Good, Rod. I seen when I was a small kid when walking into a classroom, I first saw it. And periodic table has rows, horizontal rows, and vertical columns. Vertical columns are called groups, and horizontal rows are called periods. And how many groups are in the periodic table? If you count the numbers on the top, there are 18 vertical columns. And how many periods are in the periodic table? Excluding last two rows at the bottom. 7 from hydrogen to going below to francium. So the periodic table, in the periodic table, metals are in the green color. Metals are in the green color. And what are in blue color? Non-metals. That includes noble gases, the group 18. What is in pink? The pink metalloids is in between metals and non-metals, right? Boron, silicon, gallium, germanium, antimony, tellurium, polonium. So going down in a step way. So that's what periodic table does. One thing common to periodic table is elements in a group has similar chemical properties. For example, group 1A elements are very reactive, and group 18 elements are inert, they don't react. And halogens are like group 19. They have corrosive properties, fluorine, chlorine, bromine. So we're going to look into this more. Based on the periods, based on the groups, first group is called alkali metal. Second group is called alkaline earth metals. Others don't have names. Groups 3 to 12, which are in the middle of the periodic table as a dip. Those 10 periods are called transition elements. And the noble gases are 18. Halogens are 17, group 17. Chalcogens are group 16. Group 15 is called pinictogens. Group 15 is phosphorus, arsenic, and so on. The last two rows at the bottom of the periodic table. First row is called actinides. No, lanthanides. First row is called lanthanide. Start with promethium, neodymium, I cannot see. This is kind of, I had to increase the size. Okay, the bottom row, lanthanide is the top row, and the actinide is the bottom row at the end of the periodic table. The periodic table has elements in each box. So they have abbreviations called chemical symbols. It's a 1 or 2 letter abbreviation for each element. You look at the name, English name of the compound, and abbreviate. For example, oxygen is O, silicon is Si. Others are based on Greek names. The lead should have been Le or something if you use English name. But lead's Latin name is plumbum. Therefore, it's called Pb. Plumber is those who, older days, the lead pipes are used for water. Can you think of that now? Earlier days, pipes were made out of lead. Mercury is hydrogyrium, Greek name. That's because of that is called Hg. Copper is not Co. Copper is cuprium, based on name, Latin name. So on. Iron is ferrum. Potassium is called kalium in Latin. Therefore, K is atomic symbol for potassium. Antimony is stibium, Sb. Silver is argentum, Ag. Gold is Au. Aurum, gold, Latin name for gold is aurum. So you can watch the video on chemical symbols and get to know a little bit more. Now you have to look into practice some of what you learn. In the periodic table given in previous figure, which element do you think are found in your cell phone? There's a list of elements make up the compounds and material in the cell phone. We're going to look into that in a slide that is going to come soon. For example, touch screen is made out of silica, oxygen, potassium, and conductive glass on the surface of conductive glass made out of tin oxide and indium oxide. So like that, you have to kind of know what components of cell phone are made out of what elements and compounds. Majority of material that make up of majority of material that cell phone is made up of is metals, plastic, and glass. Some of these materials are imported from different regions of the world. Therefore, it is important that we have all these raw materials available, or somebody can control the flow of raw material, that we will be in trouble. We're going to talk about that in another slide. Okay, this is the one I'm going to talk about, what elements are made out of different part of the cell phone. It's hard to read here, but I'm going to summarize. Cell phone is made up of a screen, touch screen, electronics, battery, and casing. On the screen, there's a layer on the top of the screen which is conductive. When you touch it, it conducts electricity to create a response. This conductive film on the touch screen is made out of tin oxide and nickel indium oxide. So indium oxide and tin oxide are materials that are used for cell phone touch screen. And the glass is aluminosilicate, aluminosilica regular glass, but it has more potassium to give a crack resistance. And screen also have different rare elements like lanthanum, terbium, different dionium, europium, promethium. Cell phone has different colors. When they light up, you can see different colors. The icons are created with different colors. So each color is created by these rare elements in your CD, liquid crystal, LCD screen below in the cell phone. There's a LCD screen in the background of underneath the cell phone. The electronics are made out of wiring material made out of copper, silver, gold, and some of them are included tantalum. And then the microphone is made out of certain metals which create a vibration. Microphone need to create a vibration that will be converted to electrical signal. They are made out of rare elements, dynamium, PR, TB, ND, gadolinium. There are nickel, and there are 6 of them. And the silicon chip that is used to control the electronic signals and send it to right places is on the chip. Has a logic. Chip is made out of silica, and certain places on pure silica are deposited with these 5 elements: oxygen, lead, arsenic, phosphorus, and gallium, to create the circuit board conducting. Chip has a lot of network logic circuits. They are written by depositing thin line of these metals, making it conducting. And the last one, tin and lead, are used in soldering as soldering material in cell phones. And the third component of the batteries of the cell phone is the battery. Battery is made out of lithium oxide battery, lithium, cobalt, and oxygen battery. The anode is a carbon, and casing of the battery is made out of aluminum. So battery has a casing. And also cell phone casing is made out of magnesium alloys. They are mainly metallic. Some cell phones are metallic. Some are plastic, made out of plastic with fire retardant material, bromine, and from plastic material to reduce the electrical interference, you add to plastic nickel. So that's how cell phone is made up of different elements, different components. Do you see that each component uses different elements, and each element has certain properties that are suitable for that application? One of the things we do is use chemistry to manipulate matter to give different properties. For example, if you take iron, Fe, it is I'm checking the time. Iron is made out of iron atoms. It is magnetic, is the element. Iron powder is magnetic. When iron is reacted with oxygen, the rust is formed, the red color. Rust is Fe2O3. Iron also combined with oxygen to produce a different compound called magnetite. Magnetite are in small magnet in the compasses So whole idea here is, we talked about in the introduction, when two elements combine in variety of ratios, they form two different compounds. Fe2O3 has different composition than Fe3O4. Therefore, it imparts completely different properties. So these properties are desirable and could be used in various applications. The rust in the center is red colored. Fe3O4 magnetite on the right is magnetic, but not as magnetic as iron, elemental iron. So how many of you see the idea now? We can manipulate the composition of material, make up different material with different composition to give certain desirable property, magnetic property, some of them colorful, some of them are conducting, some of them are hard, like ceramic material. So these are all chemical reactions that we do to create new materials. Now we are going to go to the most fundamental particle of matter, an atom, which are elements. Elements are made out of one type of atom. Atom is so small, we cannot see it. It's 1.4 10 to the negative meters in diameter. What is the thing written in the blue area in the middle of the slide? It's NIST. What is NIST stand for? National Institute for Standard and Technology. They are the ones who create standards for different material. This is a atomic force microscope picture, which shows things at nanoscale. Each dot is atom. This is not seen by naked eye, but this is a simulation from electrical signals that created coming from the atoms. You can see that in the nanoscale, the atoms are made out of small atoms. So watch the video below to see how scientists see atoms. So atoms cannot be seen by naked eye, but they could be imagined. But there is evidence from instruments like atomic force microscopy that they are there. Now we're going to talk about scientific notation that we use during measurement during a measurement. For example, when you use scientific method, during observation, you get certain measurements. Mostly measurements, scientific measurements, have a number and a unit, like 100 kilograms. Number part is 100. In sciences, to abbreviate the number, like 11,000, you write down that number in scientific notation. Scientific notation is to the first decimal place, and rest are shown as an exponent of 10. Small number has negative exponent, and large numbers have positive exponent. What is the number, this big huge number in the bottom of the, before the video on scientific notation? That's called Avogadro's number. How many of you heard about Avogadro's number? Do you? Avogadro's number is number of atoms in a 1 mole of a substance. You take substance, 1 mole of substance. That's the definition of 1 mole. In measurements, we also use prefixes to abbreviate, shorten the number. There are 2 ways to shorten the number: scientific notation and using prefixes. For example, 1 to the 10 to the 3 grams. 10 to the 3 is kilo. You can look at the 10 to the 3 here on the table. It's kilo. 10 to the 6 is mega. 10 to the 9 is giga. So big G, giga. Deci is 10 to the negative 1, smaller. Milli is 10 to the negative 3. 10 to the 6 is micro. The bacteria in the size of microns, micrometers. Atoms are in the nanoscale, nano view. Remember that picture has nanos, viewpoint of atoms that they wrote the NIS
Yes, sir.
symbol. That's a nano. So when you have different scale of measurement, like 32 nanometer, if you want to convert that to meters, you use these conversion factors. 1 to the 10 to the 9, negative 9 meter is a 1 nanometer. So they cancel out. This way of doing is called dimensional analysis. We use dimensional analysis to do calculation in chemistry, where the units guide the calculation. We might run into it later, dimensional analysis. Now, please watch the video on metric prefixes. Your turn to think about units. The macroscopic world around us and micro world, microscopic world, micro world, and submicroscopic world comprise. What are the examples for these different worlds? Macroscopic, microscopic, submicroscopic. Give an example, something that you see which is considered as a macroscopic object. A tennis ball, or something you can see, baseball, tennis ball, football, with dimensions like length in a half meter, quarter meter. These are macroscopic ranges. Millimeters are small, kind of a length of a coin, thickness of a coin. Centimeters are radius of a point, and meters are macroscopic, like your height is 1.7 meters or something that is more larger objects are measured by meters. You can take up a ruler and measure the length of your cell phone, and I don't have a ruler right now, otherwise I would have told you what my cell phone is, dimensions, thickness, and all that in meters. In sciences, we use meters, grams, and seconds, and liters. So you should be able to express your answers in both standard and decimal scientific notations. I'm going to stop today and do some problems at the end of the chapter, just to give you an idea where you can go and look at questions. I'm going to go to chapter 1, sample questions. That's here. I'm not going to go through the whole thing, but I will touch upon what you can do yourself. Classification of matter based on composition. Pure substance, elements, and compounds. Question number 1. Which of the following statement is correct about pure substances? Pure substances are either elements or compounds. Which one is correct about pure substances? Both elements and compounds are pure substances. For example, if you take B as an answer, compound but not element, it has to be both elements and compounds. Then the last one is neither elements nor right. That's not right. An element is pure substance with can be. Now I have to tell you this. Elements cannot be broken down further by simple means. But the compounds could be broken down to simple compounds like other elements or simple compounds. So element is a pure compound which cannot be broken down to simpler substance by chemical means. Cannot be broken down to simpler substance by physical means. Physical or chemical means you can be broken down to simpler substance by physical means. D is the correct answer. Normally, not the physical means. Chemical means the compounds could be broken down. Elements cannot be broken down into simpler substance by chemical means. Which is not an example of pure substance? Sugar, air, aluminum foil, water, block of dry ice. Dry ice is carbon dioxide, is a pure substance. Sugar is a pure substance. Air is a mixture of nitrogen and oxygen. That's why your answer is B. Aluminum foil is aluminum, made up of aluminum atoms. Therefore, it is pure substance element. Water is a compound. Now look at the number 4. Which one you think contain only elements? Look at carefully. First one contains what? Compound. Second one contains only one type of atom, element. Only elements. The third one also contains 2 elements. You see that? The question is contain only elements. Both 2 and 3 contains elements, but fourth one contains molecules and elements. Therefore, D is the correct answer. Do you see that?
Yes.
Okay, good. So you're going to go through this physical change. Now this is number 12. That's the change in the atomic view or particulate view. That first one is, what do you think first one is? Is ice. Is going to water. Is ice going to water is what? Melting or freezing? Melting, right?
Yes, melting.
So you go through this carefully. Chemical properties, physical properties, substance, process. Now, number 23, which will contain mixtures. A mixture is 2 elements, 2 different elements, or mixture of elements and compound. Do you see 3 and 4 has elements and 3 has a mixture of elements. 4 has a mixture of elements and water. So first one and second one is only one kind of substance. Element in the second one. First one has only compounds. Answer is 3 and 4. B is 3 and 4. Now you go through this. Now in the periodic table, the representative elements are the Stoll group 1 to 13 to 18 are called representative elements. 1, 2, 3, 4, 15, 16, 17, excluding noble gas. Representative elements. You will understand a little bit more when you do that. Based on periodic table, which element is non-metal? Number 31. Which is a non-metal? The bromine is found in area where it is blue, which we call non-metal. So you can answer these questions and different transition metals are on B's transition metal. Answers are there. So carefully go over there and you will understand which group boron is. Right. The names of compounds also we have questions. Okay, I'm going to stop today, okay?
Okay.
You guys read the slides and answer, go through some questions, okay? So
Okay.
it's a must. You should be doing that, okay? Have a great afternoon, evening,
You too.
and I
Okay.
will see you on
Wednesday.
Wednesday. Yes.
Thank you.
Okay.
Take
All
care.
right.
Bye-bye.
Bye.
Bye-bye.
What's your
Bye.
daughter's name?
I'm Caitlin.
Katen?
I'm the girl in the front. My mom is in the back.
Oh, okay.
Yeah.
Good. Okay, let's take a meet on Wednesday, all right? Well, I'm going to end the meeting.